Now, once you have find out the Followpos, now you have to do something. So the main thing is done already, right? Now you have to consider. Now you have to consider what was the first pos of the root node, which is this, that is 1 2 3, right? The first pos of the root node is to be considered, and what is that in this case? It is 1 2 3. So this is the, I'll take a new page. So this 1 2 3 is the start state. So we are now starting to draw the transition table of the DFA. You know, you can, if you draw the transition table, then you can convert it to the DFA, right? State diagram. So what are the symbols possible? A and B. So 1 2 3 the start state. Okay, let's go back. So now see what we have to find. 1 2 3, 1 2 3 is a state, because this is the first pos of the root node. So 1 2 3 on A, we have to find out, right? So 1 2 3, this particular node on A, what will be the transition? We need to find that, right? Now how to find it? Simply take 1 2 3 and find out what are the positions which correspond to A. You can see this 1 is corresponding to A, and this 3 is corresponding to A. You can see from this diagram, right? 1 is corresponding to A and 3 is corresponding to A. That is why we'll take the union of Followpos of 1. We'll take the Followpos of 1 and Followpos of 3. Okay, so what is that? You can check it from here. Followpos of 1 is 1 2 3. Followpos of 3 is 4. So what is the union? 1 2 3 4. Write it. 1 2 3 4. So we can write on A, it will move to a new state, which is 1 2 3 4. As simple as that. Now what will be the transition of B of 1 2 3? So from 1 to 3, what is the position which is corresponding to B? It is 2. We'll simply find out what is the Followpos of 2 and write it here. So the Followpos of 2, as you can see from here, it is 1 2 3, right? We can simply write here 1 2 3. Now, you know, while drawing our DFA, whenever a new state comes, we need to find the transition, right? So 1 2 3 4. Now you have to check 1 2 3 4, what will be the transition of A? So from 1 2 3 4, which positions are corresponding to A? 1 and 3. So again, we have to find out the Followpos of 1 and 3. That is 1 2 3 4 again. What is the position corresponding to B? So 2 is a B and 4 is a B, if I'm not wrong. You can check it from here. 2 is the B and 4 is also a B, right? So we'll simply find out the union of the Followpos of 2 and Followpos of 4, right? So what will be the result? You can check it from here. 2 and 4, it is 1 2 3 and 5. So 1 2 3 5, right here. 1 2 3 5. Okay, the next is we have got a new state 1 2 3 5. So 1 2 3 5, from 1 2 3 5, which are corresponding to A, 1 and 3. So again, this will be 1 2 3 4. What are corresponding to B? 2 and 5, right? So 2 and 5, you can check the Followpos. 2 is 1 2 3, 5 is 6. So it will go to 1 2 3 6. 2 3 6. Now again a new state. I'll simply write it as, now 1 2 3 6 on A. What are the positions corresponding to A? Is 1 and 3. Again 1 2 3 4. And which are the corresponding positions for B? It is only 2, because 6 is corresponding to hash. So only 2. So 2 means 1 2 3. Followers of 2 is 1 2 3. 1 2 3. Right? Now what is the accepting state here? The state which contains the position corresponding to hash. So this is the final state. Okay, we can have more than one final state, you know already. So this particular state has 6 in it, so 6 is corresponding to hash. That is why this is the final state. Now if I want to draw the DFA, it will be like this: 1 2 3, the start state. On A, it is moving to a new state, 1 2 3 4, right? And on B, it is going into the same state. It is like this: 1 2 3 4. On A, it is going to the 1 2 3 4, and on B, it is going to a new state, 1 2 3 5, right? And 1 2 3 5 on A is going back to 1 2 3 4, and 1 2 3 5 on B is going to a new state, is 1 2 3 6, right? And 1 2 3 6 on A, it is going back to 1 2 3 4, and on B, it is going back to 1 2 3, right? And this is the final state. So this is your corresponding DFA. You can draw it in a simple way like this: A, it is going to a new state B, B on B is going to a new state C, and C on B is going to a new state D. Is the final state. And A on B is going to the same state, B on A is going to the same state, C on A is going back, C on B is done, D on A is going back to B, D on B, I think 1 2 3 6 on A is going back to 1 2 4. Okay, 1 2 3 4, and on B it is going 1 2 3. You find what a regular expression directly to a DFA. So the algorithm you'll find in the book. There is internet, you can find it. But this is a working example, and you can try it on any regular expression, right? Thank you. See you in the next video.